Welcome to our series of videos on quality management concepts. Hello friends. In this video we will see about scatter diagram, used to observe and visually display the relationship between two variables, often referred as x and y variables. Scatter diagram is graphical way of establishing correlation between two sets of data. Before understanding how to draw scatter plot, let's first understand what is correlation. Correlation is a measure of strength of relationship or association between two variables. Variables are often related. The increase of one variable can lead to increase or decrease of another variable. In this relationship, value of dependent variable, often referred as y, depends on the value of independent variable, often referred as x. Example: the more time you spend running on a treadmill, the more calories you will burn. Correlation coefficients are used to measure how strong a relationship is between two variables. There are several types of correlation coefficient, but the most popular is Pearson's. Pearson's correlation, also called Pearson's R, is a correlation coefficient commonly used in linear regression. Formula in the screen is used to calculate the correlation coefficient, and the resultant value ranges from -1 to 1. Value close to +1 indicates strong positive correlation and close to -1 indicates strong negative correlation. If the value is closer to 0, then it indicates no correlation. Let's also see how correlation coefficient is calculated in Excel.
Hello friends. Now we will see how correlation coefficient can be calculated. I'm going to show two methods. One is how we can directly calculate it using an Excel function, like how you calculate average using a function in Excel. Similarly, how you calculate standard deviation using a function in Excel. Similarly, you can calculate correlation coefficient also directly using a function in a Microsoft Excel. So first, let's see how to do that. So in your Excel file, if you have your X and Y data collected in two columns, X data in one column and Y data in another column. So basically these are two variables. So in Lean Six Sigma language, we call it X and Y, but generally in a correlation concept, we call it two sets of variables. So here, if you see, there is one set of variable, the data is collected here, there is another set of. So how do I calculate correlation coefficient? So correlation coefficient is generally represented with the symbol R. So what is the formula for me to calculate correlation coefficient, or what is the function that I can use? For example, if you see here, so I'm going to delete this value. I'm going to say is equal to CORREL. So this is the function CORREL, and then I select the first set of variable, the column in which the first variable is saved. I put a comma, and then I put a second set of variable, and then I close the bracket. So then the value that I get is the correlation coefficient. Very simple, very straightforward. But for others who would like to understand how or what is happening behind this, like for example, if you say average, we just say average, but behind that function average, what is happening? Sum of all data points divided by number of data points. Similarly, what is happening behind this CORREL, if you want to understand? So this is the formula. In the video, we have seen this formula before. So let me try to break this formula step by step so that you can understand how does this formula work. One thing we need to be very clear whenever we are looking at any formula. On the outset, the formula may be quite big, sometimes complex, sometimes difficult to understand. But if we break down that formula into smaller pieces, it becomes very, very easy to understand. If you see here, the formula says R is equal to 1 divided by n minus 1, summation of x minus x bar divided by sx multiplied by y minus y bar divided by sy, right? Okay, now let's go one by one and try to understand what are these x bar, sx, y bar, sy, what is that n minus 1. Let's understand all these things one by one. So x is nothing but your x variable, right? X is nothing but your x variable. You have x variables collected in a column. Similarly, y is nothing but your y variable, which is collected in a column. Now, what is x bar? X bar is nothing but average of these x variables. So how do you calculate average of the x variable? You can calculate average of the x variable by using the average function. As I told you before, if you see here, if I say is equal to average of my x data points, I'll get x bar. So this is called x bar. So similarly for y, if I say is equal to average of my y data points, I'll get my y bar. So x bar stands for average of x data points, y bar stands for average of y data points. Similarly, sx, sy. So sx represents standard deviation of x, sy represents standard deviation of y. So again, in your Excel, you can use the function is equal to stdev. You can select x values, you will get standard deviation of x. Similarly, if you say is equal to stdev and you select the y data points, you will get standard deviation of y. So in this formula, your x, we know what is x, y, we know what is y, x bar, y bar, which is average of x, average of y, sx, sy, standard deviation of x, standard deviation of y. So this part of the formula is now being broken down into smaller pieces. Now we'll try to stitch this formula together. So what is this formula saying? The first part of this formula says x minus x bar divided by standard deviation of x. That means 1 minus average of 1, which is 2, divided by standard deviation of x, which is 0.82. So x minus x bar divided by standard deviation of x. If you see here in this formula, that is what I have given. So in the cell B4, you have your x value, B9, you have your average of x value, and B10, you have standard deviation of x value. So to freeze these two columns, I have just used the dollar symbol so that I can just copy paste this formula one below the other. So in each of this case, what happens? 2 minus 2 divided by 0.82, which results a value of 0. Similarly, 2 minus 2 divided by 0.82, which results a value of 0. 3 minus 2 divided by 0.82, which results a value of 1.2. So what we have done is we have separately solved this part of the problem. And now similarly, we are going to solve the other part of the problem. What is? Y minus y bar divided by standard deviation of y. So 1 minus 3 divided by 2.6, which gives us minus 0.93. And same concept, I have freezed the y bar and standard deviation of y cells using the dollar symbol. So if I copy and paste this, I will get the corresponding values for each value of y. So 2 minus 3 divided by 2.6, which is minus 0.46. Similarly, for the y value of 3 and y value of 6. Now, if you see the formula carefully, it says make a product of these two components. So we already have these two components individually calculated. Now I'm just going to say E4 multiplied by F4, product of these two components. If you see the formula here, E4 multiplied by F4. So I'm going to make a product of these two components and I'm going to again copy and paste it so that I can get it for all the values, corresponding values. Okay, so I have created this component, I have created this component. Now I created a product of both. And then the formula says you do a summation of this product. So here I have the product values. So I'm just going to again use an Excel function called sum of these products, right? Sum of G4 to G7. So we have solved up to this part of the formula. So summation of x minus x bar divided by standard deviation of x multiplied by y minus y bar divided by standard deviation of y, right? Okay, so we have solved up to this part. Now the last part is you need to multiply this component with 1 divided by n minus 1. So what is n here? N is number of data points, right? So totally we have 4 pairs of data. 1, 2, 3, 4. So we have totally 4 pairs of data. So why n minus 1? Maybe in another video, I will explain about degrees of freedom, why we want to divide n minus 1. So at this point of time, you can consider this formula is having n minus 1 considering degrees of freedom. So in this case, 1 divided by n minus 1. So if you see the formula here, what I have done, I have made 1 divided by 4 minus 1. So in our case, n is equal to 4. It is 4 minus 1 multiplied by this value that we have already calculated. So if you see what is happening behind your CORREL, We have just tried to convert it step by step using how you have to solve this. In case if you want to really understand what is behind that CORREL, what is the formula, this is how the formula works. So the correlation coefficient, as you all know, is an indication of how strong is the relationship between two sets of data. Closer to +1, strong positive correlation. Closer to -1, strong negative correlation. Closer to 0, no correlation. So how you will calculate correlation coefficient? If you don't want to go too much into the formula, just use the Excel function CORREL. Select the first set of data, put a comma, and select the second set of data. It will return the value, the correlation coefficient value. But if you want to understand how does it work, here is the formula, and here is the step-by-step instruction. Right? Thank you, friends.
Among the different types of correlation, let us first understand what is positive correlation. A positive correlation is a relationship between two variables in which both variables move in the same direction. Therefore, if x increases, y will also increase, and if x decreases, y will also decrease. Example is tenure increases, productivity will increase. Based on the strength of relationship, it is further classified as perfect positive correlation. For this type, correlation coefficient value will be +1. Strong or high positive correlation. For this type, correlation coefficient value will be above 0.8, and low positive correlation. For this type, correlation coefficient value will be between 0.3 to 0.8. A negative correlation is a relationship between two variables in which both variables move in the opposite direction. Therefore, if x increases, y will decrease, and if x decreases, y will increase. Example is tenure increases, average handling time will decrease. Similar to positive correlation, negative correlation can also be classified as perfect negative correlation. For this type, correlation coefficient value will be -1. Strong or high negative correlation. For this type, correlation coefficient value will be below -0.8, and low negative correlation. For this type, correlation coefficient value will be between -0.3 to -0.8. Curved relationship is a strange correlation, where it starts with one type of correlation. Let's say positive correlation. After a point it becomes negative correlation. In this example, as speed increase, mileage also increase. But beyond a point, as speed increase, mileage decrease. Partial correlation is a relationship between two variables in which both variables get impacted by the third variable. In this example, as tenure increase, accuracy also increase, but only till some time period, and after it become a scatter. And finally, no correlation, where x and y do not correlate at all. Let us now see a step-by-step explanation of how to draw scatter diagram in Microsoft Excel and Minitab.
Hello, friends. As part of this video, we have already seen what is correlation, how correlation coefficient need to be calculated, and within correlation, what are the different types of correlation. For example, the positive correlation, negative correlation, curved relationship, partial correlation, and no correlation. Using correlation coefficient, we can statistically establish the strength of relationship between two variables. Depends on what is your correlation coefficient value. You can decide whether it is strong positive correlation or strong negative correlation, or for that matter, weak positive or weak negative correlation. That is statistical way of establishing the strength of relationship. Now what we are going to see is how do we graphically draw a scatter diagram, which is otherwise called a scatter plot, and establish the relationship. Right? So we are going to see how to draw a scatter plot in Excel file, and we are also going to see how to draw a scatter plot in Minitab. So let's start with how to draw a scatter plot in Excel file. Right? So as I told before, whenever we deal with scatter plot or for that matter correlation, it is always pairs of data. So here if you see tenuity in days, so number of days you are experienced in a process, which is your y. So y variable. So that is collected in one column, and productivity, average how many units you are able to produce per day. So that is the average productivity. So in a group of 19-member team, so we have collected the tenuity in days, and we have also collected the productivity per day. So for each of those team member, we got the value of what is the tenuity. We also got the value of what is the productivity. So similarly, we have collected this data for 19 different individuals in a team. So now how to draw a scatter plot for this? So when you want to draw a scatter plot, you need to highlight or you need to select the X variable, and then you need to select the Y variable. Once you select the X and Y variable, then you can go to insert, scatter. So inside scatter, the first option. So I'll hold here for a minute. So select data point, click on insert. After clicking on insert, click on scatter, and in scatter the first option. And when you select this, you get a graph which looks like this. So first of all, let's try to adjust the scale of the graph so that we get to see the data that we are concerned about. That means in a graph, if you have a lot of white space, that indicates that you need to adjust your scale accordingly. So we don't have any data point below 60. So let's keep the minimum value as 60. And let the maximum value be at 100. Similarly, here we don't have any data point less than 250. So let's adjust the scale, make it 250. And maximum be 500. Now, when you create a graph like this, you can understand something. What is that? When X increases, generally in a graph, your horizontal axis is X and your vertical axis is Y. So when X increases, your Y also increases. What do we mean by that? If tenuity increases, productivity also increases. You may ask me, how do you say that? So I click on this data. So how do we got this particular dot? For example, if you keep your mouse pointer here, it says 275.74, right? So what is 275.74? If you see this first pair of data, in X value you have 275, in Y value you have 74. So what Excel is doing is, Excel is trying to plot the value of 275 in X-axis, right? And similarly on your Y-axis, Excel is trying to plot the value for 74. So where your 275 and 74 are intercepting, at that point you have a dot. So what happens? So when 275 and 74 intercepts, you get a dot here. Similarly, if you want to repeat this activity for, let's say, another value here, let's say we will take this data point which is 420 here, 420 and 80. So if you see here, you have 400 here. So 420 is something here, somewhere here, right? 420 and 80. 420. This value here. Keep the mouse pointer. Just a minute. You keep the mouse pointer here, it is 410.85. Sorry, it is 410.85. So where you have your 410 and 85, you keep the interception point. That's again you have a dot. So similarly, for each of these dot, there is a Y value and there is a X value, and the interception point between X and Y is considered for this dot. And as you see this, if you add a trend line to this trend line will indicate a trend, and it's a linear trend line that we are going to add. So if you add a trend line, the trend line indicates it starts from bottom left hand corner and goes to the top right hand corner, which otherwise means if your X is increasing, your Y also increases. So this kind of a pattern that you see here is what we call it as positive correlation. Positive correlation, as you saw in the definition before in this video, when X increases, your Y also increases. If X decreases, your Y also decreases. So this is what we call it as positive correlation, right? So let me paste this positive correlation graph here. So now this is how we have drawn it in Excel file. So if you want to draw the same in Minitab, you can copy the same data, paste it in Minitab, your X value and Y value. So you can go to graph, The very first graph under the tab graph, the very first graph that we saw is scatter plot, right? So when you click on scatter plot, you can create a scatter plot without a regression line. You can also create a scatter plot with the regression line. So what is a regression line? Maybe in another video, we will see in detail what is a regression line. How does we make use of this regression line? It is an advanced topic of correlation. Once we understand correlation, we'll be able to make use of the concept of correlation to take it forward to regression. At this point of time, we will try to draw a scatter plot without a regression line, right? So select a simple scatter plot. My y variable, so my y variable here is productivity. My x variable here is tenure in days. As tenure in days increases, my productivity also increases. So that is why we call tenure as x and productivity as y. And now if you hit OK, it gives you a graph which is very similar to what we have drawn using the Excel file. I'll just paste these two graphs next to each other so that you get to see the same picture. So what you need to do as adjustments as your rows and the scale in your X and Y, all those things get automatically adjusted, and that is how you get a graph which is almost same, similar to each other, right? So friends, I hope this video gave you an idea of how to draw a scatter plot using Excel as well as in Minitab. Maybe one more graph I will just draw so that you get to see a negative correlation scatter plot also. The process is very simple. Just for your understanding, let me draw it one more time in the Excel. So I select this data. So if you see tenure and AHT, these two are negatively correlated. If one increases, the other will drop. As I get more tenured in the process, I will be able to perform my activity much quicker so that my average handling time reduces. That is the conceptual understanding. And the same also get established when you draw a scatter plot, because the pattern is quite opposite. So earlier it was the curve or the pattern started from bottom left hand corner and it went up to top right hand corner. But now if you see, it will be exactly the opposite. It will start from the top right hand corner and then it will come down to it will start from top left hand corner and then it will come down to bottom right hand corner. This kind of a relationship says if your x increases, your y decreases. So this is what we call it as negative correlation. So just one more time, if you want to see how this can be drawn using Minitab, you just need to copy the data, paste it here, and then you have to go to graph. In graph you have scatter plot. You can select this one. You can say okay. Your y variable this time is average handling time, and your x variable this time is tenure in days. And when I say okay, I get a graph which represents negative correlation. So this is how we can graphically establish what we call it as positive and negative correlation. I hope you already saw in the early stage of this video or early part of this video how to calculate correlation coefficient. So here I will also do that. So I say is equal to CORREL and I select the x variable, put a comma, select my y variable, close the bracket. It will give me my correlation coefficient. So here if you see, the correlation coefficient is greater than 0.8, which indicates a strong positive correlation. And if you see the graph also indicates a strong positive correlation. So similarly for the other case, if you see, if you want to calculate the correlation coefficient, I select my x value, I select my y value, it indicates minus 0.869. A value that is lesser than minus 0.8 indicates a strong negative correlation, and if we see here, it indicates a strong negative correlation. So friends, hope this part of the video will be helpful for you to graphically draw a scatter plot and establish whether the x and y variables are correlated or not. Thank you, friends.
Thanks for watching our video. We hope this video was useful. Please share this video to your friends and colleagues. Subscribe to our channel for more quality management related videos.